Hello everybody, welcome to another video of learning malware analysis with Part T. In this video, we'll be covering data encoding. Some of the key things we'll be answering in this video will be what exactly data encoding is, and this will be a recap because we did cover a bit of the basics as to what it is. Then we'll look in a bit of a more deep dive as to some of the methods used for data encoding and the reasons why malware developers usually need to do this. So let's give a recap. Now, data encoding is basically giving yourself the ability to have malware stay hidden whenever you want it to not show intent. So for instance, an analyst is looking at your malware, you really want to confuse them as to the intent of the software. This is an analyst within an antivirus company, for instance. It would be prudent to have them think that the malware isn't really malicious at this point so that it's whitelisted. Some of the more common methods include using simple ciphers. In this case, let me give an example of the Caesar cipher, which is basically a transposition cipher. So we can say we're doing a transposition of 3. So where letter A becomes C. So if you look at something simple like a PE header in the hex space, you would want to move, for instance, the 45 3 steps forward. So you'd have a 7 and an 8 instead of a 4 and a 5. So that is basically what a simple cipher like Caesar cipher is. So you create a key space based on what number you want to transpose with. Another common method is using XOR for quite a number of reasons. XOR is very efficient when it comes to malware. This is because if you look at it, XOR, when run in a certain number of times, for instance, if we run once, we get a sort of encrypted data using a certain key. So with XOR, you just need a key. So when you run once, you get data in a different form. When you run twice against the same key, even with the encrypted data, you do get back your original data. So this gives us 3 forms of XOR. So how malware developers usually use it, they can XOR a register with itself. So where you have, for instance, XOR with another EDX register, this would technically mean that you null a register, or rather set it to 0. That's because XOR will only work if the inputs are different. It will never work if the inputs are the same. So for instance, if you have pactab and pactab as the key, XOR will not have a change in state. If it's pactab as the key and then malware as the input, it will give you a different output. We'll look at this in a bit. So XOR has to only give substantial data when the inputs are different. So if you look at again, another method is XOR a register with a memory reference. You may have a constant key, but you do encode in a loop. So for instance, all the contents of a register have the key as, or rather, you XOR a register with, or a register or memory address, for instance, or rather a particular memory reference that you're jumping to with a constant key. So what happens is we can set the key again, in this case to malware, and then we will have pushed the word pactab, for instance, to a register, and then we'll encode each letter within that to something else, or rather to the key constantly. So when we are decoding, we will use that only one key. Another instance is, this is a more stealthy one, but it will still have overhead on execution, XORing a register memory reference with another register memory reference. Now, as you may guess, that makes it very dynamic and becomes harder to find the pattern. However, if you consider some scenarios, if an XOR key contains only 1 byte, that leaves only 256 possible encryption keys. So that is a very small space, which means another method would be the malware, if execution time is not an issue, would choose to keep itself brute forcing the key. This makes it harder even for an analyst to find. So why do people do this? The first one is the most common, which is hiding configuration information. You do not want people to see sensitive information. Consider it to be a Trojan, for instance, and it does have to communicate with a command and control center. You do not want people to find the command and control center of your Trojan. Another thing, if you consider things like keyloggers and backdoors, they may want to temporarily save information on disk. For instance, it has taken screenshots of videos, it has taken keystrokes. It will want to keep a sort of encrypted database before sending it over to the attacker. And then another thing is storing strings and just decoding them when needed. This again helps hide malware's intent while it's in the victim's disk. And the last one is the most obvious, where we do want to simply be seen as the good guys, yet we are not. I hope this sheds some light. Now, before we close this video, it will be prudent to look at an example. So I will run a simple script that does show one of these concepts. This is basically the second one, where we have a constant key and then we're running it through multiple bytes just to see how it will look like. The representation here will be in hexadecimal, as it's the most commonly used. So just to take you through it, what we have here is the word packed up. Now within a binary, this is how it will be represented in hexadecimal. So we will take just a single byte, just to keep it simple, a single byte key, which is 4D. The 0x is a denotation that this is hexadecimal, so that shouldn't be an issue. What we are focusing on is this. So if we take the first letter, which is P, this is how it is. It will be considered a 0x70 or 70 in this case. Now the 70 reference, when passed through this key, becomes 3D. However, if this was 0x70 and the key was a 0x70, this would have no effect. You will still have a 0x70. Now the same thing applies for the letter A, which was 61, it becomes 2C. 63 becomes 2E, and so on and so forth. If we use the same key and run it against these new references, as you notice, we do get back our original string. So the malware at rest may have this, but when it's running in memory, this is what will be used. You will find this bundled up with your video and you can have a look at it. It's a very good example as to how XOR works and how it can be used. In the next video, we will be looking at covert launching techniques, which is basically how malware manages to launch itself in mostly secure systems. Thank you.